Yeah, welcome back. Uh, so I asked you a question. Try this question. How many outcomes do you see in this table, from this table, in the sample space? The answer is four, because if you think about the experiment, it is more clear because we restricted our attention to only two variables. The experiment can be thought of as choosing a random person and asking two questions. And then the possible answers to these these questions is one outcome. Any possible answers is one outcome, and there are four possible outcomes: male with health insurance, female with health insurance, male without health insurance, and female without health insurance. Right? And also, it is clear from the table there are four probabilities. They are separate type of answers, different types of answers. So each of them is one outcome in our survey when you restrict them to two questions. So the answer is 4B. In the classroom, I used to use iClickers to to have students try these questions, and I use that for attendance. But unfortunately, it's not possible. But also, it's nice because you have unlimited time. You may try this by yourself by pausing the video. So please utilize these questions to um, organize your thinking and just to catch up what I'm doing, and if needed, review the previous videos or materials so that you are following. Okay. Okay. Anyhow, uh, now because we have two variables, the structure of outcomes is a little bit more complicated, but still it's acceptable. If there are more than two answers possible for for a question, then you'd have more outcomes. And then now we have to think about the difference between event and outcome. I previously we discussed event as a set of multiple outcomes, and this concept, the distinction is particularly more important when you have multiple variables. So in general, the probability of an event is the sum of probabilities of outcomes included in the event. I have said the same thing before. It is a general principle. You can apply to this principle to any event. So, for example, suppose that an event includes these three outcomes: female not covered, female covered, male covered. These three outcomes. Then the probability of this event would be sum of these number three probabilities. Excuse me. There is no difference from the dice roll example. Simply the sum of probabilities of the outcomes is the probability of an event. So, and from now on, our main object will be an event rather than an outcome. So, we are going to use uh, notation, mathematical notation from now on. And let's define two notations for two basic events. One is F. I'm going to denote female, the event being female, as F. And I'm going to denote having on health insurance as H. So F and H are the notation for these events. They are the basic events from these for two variables, right? Gender and health insurance. These are two variables, and from them, it is most natural to define basic events in this way. And their probabilities, the probability of the event is denoted as just PR, probability, as a function of event. Because the probability is assigned to an event, you can think it as a function of an event. So probability is a function, a mapping from an event to a positive number between 0 and 1, or 0% to 100%, right? So you can understand it as a function, probability of F, probability of H. And what we are going to see from now on is that even if we have multiple variables, these two basic events, are enough to express any kind of event in our example. So if you manipulate these two events, then you can make up a more complicated or new events. Okay, now then let's study the first manipulate operation on events. Simply, consider we defined female as F. Female is an event. So event means when you choose a random person, what is the probability that the person is female? So that's the event we define as F. Then how can we define male? Male is automatically negation of female, just the complement of it. So male is the event that contains all the outcomes not included in female. This is exactly so all the individuals who are not female are male. So and it's exactly the complement set. So we call this complement event of F, the complement of F, and denote it as F superscript C. Of course, this C stands for complement. So F complement, we read it as F complement. That's female complement is male. So it's intuitive, easy to understand, or you can think it as negation. Similarly, we defined H as those who have health insurance. Those who have health insurance, then we can define those who do not have health insurance as H complement. So H superscript C denotes the event that a person does not have health insurance. So point is, it's negation. The negation is the complement in probability notation. Let's think about this then. What is the probability of complement? It's simple. What is this? It is probability of an event that is F complement. So try this by yourself, and I will see you in the next video.